Welcome to 3.17. Here we're going to identify and understand horizontal asymptotes, obviously similar to vertical asymptotes, but behave a little bit differently in some ways. Let's take a look. Alright, so to start off with, go ahead and write this down and complete the discovery problem here. Use the function f of x to complete the following, and the function is 100 divided by x squared. And so what you want to do is complete the table with the correct y values. I've already put in the x values that you want to input. You can use a calculator or Wolfram Alpha to do this. Just make sure that for your negative values, you're putting the entire value in parentheses and then squaring it so that you're squaring the whole negative value. And what you want to notice is what happens to the y values as the x values approach positive infinity, what happens to the y values as the x values approach negative infinity, and will the y value ever reach 0? So you should fill out your table and then have an answer to both B, C, and D. And for D, make sure you explain so that you can kind of understand why or why not this will occur. Okay, hopefully you found this fairly easy and quite interesting. Notice that if I begin with the value at which my function is undefined at 0 here, that should lead me to understand that I have a vertical asymptote at x equals 0, or in other words, along the y-axis. And now I can start moving away from that vertical asymptote. Okay, so instead of moving closer to it, I'm going to think about what happens as I move farther away. So at 10, notice 10 squared is 100, and negative 10 squared is 100. So this will give me y values of 1. Now, 100 squared and negative 100 squared is going to be 10,000. And so 100 divided by 10,000 as a decimal will give me 0.01. Getting much smaller. Okay, let's try 1,000. So 1,000 squared will give me 1,000,000, and 100 divided by 1,000,000 as a decimal will be 0.0001. And you might be curious, you might try, an x value of 1,000,000 or something like that, and you'll see that you're just going to get an even smaller and smaller value that appears to be getting closer to 0. However, using common sense, we can see that no matter how big of an x value that we evaluate our function at, we're never actually going to truly hit 0, because we're always going to have some sort of fraction where the numerator is not 0. And we know that that's the only way we can actually have a fraction be equivalent to 0. And we can also see that from both sides, as we move out to the left and as we move towards the right, in other words, as x approaches negative infinity and as x approaches positive infinity, our y values are getting closer and closer to 0. So if we take a look at the graph of this function, which I'll pull up right now, we can see this very clearly. Obviously, our vertical asymptote occurs at x equals 0. We can see that here. And then as we are moving towards positive infinity, as x approaches positive infinity, our y values are getting smaller and smaller. And as we approach negative infinity, they are also getting smaller and smaller. And they are approaching 0. They're never going to hit 0 or actually go beneath 0 because of the makeup of our fraction, our rational expression. And this is a horizontal asymptote. Just as the vertical asymptote runs vertically, the horizontal asymptote dictates what happens as x moves farther to the right and as it moves farther to the left, and of course is a horizontal invisible line. Let's go ahead and define that now. So the definition of a horizontal asymptote is an invisible line. We can use y equals whatever that value is, and we'll use b here, y equals b, for the graph of a function y equals f of x. If f of x approaches the value b as x approaches positive or negative infinity. And this way of speaking should be familiar because it's the same way we described the vertical asymptote. So we might say f of x approaches this value b as x approaches negative infinity, or as x approaches positive infinity, right? Because that will mean that our function, as we move further to the left and further to the right, is going to be getting closer to this particular value b. And just as we made a table in the previous situation, we can continue making these tables to identify where these horizontal asymptotes occur. And we're going to make 3 tables to identify some horizontal asymptotes and try and learn a rule that we can apply that will be much more efficient than making a table at all times. So let's go ahead and try this out. All right, so here's what you're going to do. You're going to first identify the degree of the numerator and denominator, and then you're going to find the horizontal asymptotes by making a table of values, just like I did in the discovery problem. So if you need to go back and look at that again, you can do so. You can use the exact same values that I used in the discovery problem, or you can choose your own. You just have to make sure that you go far enough out towards positive infinity and far enough out towards negative infinity to make a conclusion. Okay, let's talk about the degree of the numerator and the denominator real quick as we look at f of x together. So the numerator is x squared minus 1, so the degree is 2 because the highest exponent I have is a 2. And in the denominator I have an x to the 4th, and so my degree is 4. Notice here the leading coefficient is 1 in my numerator, and in my denominator the leading coefficient is 2. So that's something you might want to pay attention to as well. All right, go ahead and complete these. I'll be checking that you have tables and an answer to A for all of these. And so use your table to conclude what your horizontal asymptote should be. So you should have a horizontal asymptote, in other words, an equation y equals something that dictates what your horizontal asymptote is. Then, once you've done that, you're going to want to make a conjecture as to how you can determine the horizontal asymptote simply by looking at the degree and the leading coefficient of the numerator and denominator. So go back, take a look at these 3 examples, and write a sentence or two about how you think you could do that, and we'll discuss it together on Monday.